Let's see, we're going to start with the factory tour. Are we ready to go?
Yeah, 3, 2, 1, let's go.
All right, fantastic. Hi, everyone. I'm Richell. I'm the founder and CEO of System76. And Pavel's in Colorado and kind enough to come in for a factory tour. So I'll take you around.
All right. Yeah, that would be cool.
Let's see, this is kind of the beginning of the operation. And if we turn around and look, we'll go this way. How about we go around this way? So in the beginning, when we started shipping Thelio, there was we had press come in, and it was, and all the feedback was, it's incredible how quiet it is. And then we started shipping them to customers, and we were getting some negative feedback about the acoustics. And it turns out that all the factory noise was like distorting our perception of the sound. So we built this cube here, and this is a soundproof cube where we do all of our acoustic testing. So as desktops evolve, they go into the cube, and we do acoustic testing to ensure that we're meeting a new baseline that's improved acoustics, or getting even quieter, because quiet desktops are a really important part of our design process.
Yeah, kind of a quick question. Can you take naps there?
It gets very hot. So it's small and completely padded, and very thick drywall, and all the characteristics for, and installations, all the characteristics for a good sound cube. Not a great place for sleeping.
Yeah.
I've had some podcasts in there, and by the end of it, we're sweating.
Yeah.
It does have a really nice sound quality, though. All right, so as we go through, here's Emma. Emma, say hi.
Yeah, Emma.
Say hi.
Hi. Hi.
This is Pavel.
Yeah.
He knows you online.
Yeah, I know you online. I know everyone from System76 online.
Yeah.
Yeah.
Right.
Whenever you see a comment on System76, the first one should be from me.
Yeah. So the tour is a little bit backwards. What you see first is the final assembly. So desktops are built to order, and then we have some pre-builds as well. So I'll show you that section. This is the desktop build section. So in here are products like Thelio Mira. These are prepared, they're benched, and they're ready to be assembled.
Should I buy one now?
Always, I think is the correct answer to that one. This is a assembled Thelio Mira. So we have the dual cooling chamber. This chamber is for cooling the GPU, and this chamber is for cooling the CPU. When the top is on, this has access to cool air from the exterior, so the CPU itself has its own cool air intake and exhaust.
Yes, they've always looked very beautiful, like first time touching it.
Yeah, the quality is pretty interesting. You'll see as we go through the tour how different our approach to quality and all the small details that we do to make it better than your average case.
Yes,
right.
That's for sure.
Right. So back this way, we have a lot of dogs in the factory. You'll see that as well. This is a new puppy.
Hey, puppy.
He's a little shy.
Yeah.
All right, we'll come back this way. Hey.
How you doing?
Great.
Good.
Building more Thelio Miras.
This was actually a Spark.
A Spark, a Thelio Spark. This is a partially completed major. So this duct is going to go here.
Stress test. Yeah, be careful.
Yes. So we're doing, so they're going to start some stress testing. Before products go out, everything is stress test, and there's a burn-in test to ensure that memory and GPU and CPU are operating optimally. And so that operates for a few, I believe it's overnight for every order that goes out.
Yeah, is it for Halloween or?
Yes. Decorations pop up for every season, every holiday.
Yeah, your Halloween parties is always quite nice.
Yeah.
Yeah, and since I've been following you for quite some time, I'm wondering if you have like any prototypes of Virgo. Is the laptop you've been working on?
Nothing that I can show.
Okay, yeah. I mean, like, I commented a few times, when is Virgo going to be released? I assume you're kind of busy with releasing Cosmic now.
Right. We have a lot of projects going on, and so progress happens as the teams are focused on them. So this is a JIT card, so it's a lot of go, no-go parts. So we use this to ensure that every PC has the exact same layout and tolerances.
Oh. Chico.
Through here is finished Thelio stock that's ready to be assembled into final orders for customers.
I have a big car, I can grab a few.
This is the beginning of the production side. So we just saw assembly, and this is the build team, and this is the production side of the factory. I'll ask for some of the machines to be opened up. Like this is an impressive laser. As we go around, we'll come back and I'll tell you why we added that to the factory. But from this big door here in front of us, that's where all the raw materials come in. So these sheets of aluminum come in there, and one of the differences with Thelio is that we use 1.5 millimeter aluminum. Most chassis are made out of 1 millimeter aluminum, so it makes our chassis much more durable and much more rigid.
And how many layers do you process a day? How many of these do you process a day?
It depends. So we work. The factory works just on the demand that's coming in. Sometimes the demand spikes and the amount of production increases, and sometimes a bit lower. And what we're doing is building up stock for those spikes. Over on this side these are our aluminum extrusions. So things like the launch keyboard is made out of this aluminum extrusion.
Wait, the keyboard I bought like 4 years ago was made from this.
It started out like that, yes.
Well, the final version looks much better.
This is a laser punch machine. Say hi, everyone.
Hi.
So it's called a sheet dragger because you take the sheet, you pull it over, and then there are clamps that grab the sheet and it pulls it in. That's the X-axis or Y-axis, I don't recall exactly.
Okay.
It pulls it in one of the axes, and then the head moves in the opposite axis, the X-axis and the Z-axis. It's a punch machine as well. There are a bunch of tools along the clamps, and those tools are loaded from the back. Punching is faster than lasering and also doesn't add heat. Lasering adds heat to the material, so if you have too much lasering in one position, it will start to distort the material. So you use punching in those cases. Now the machine is about to start up. Are we going to start a job?
That is moving fast.
I have an error.
Okay.
Unfortunately, right as going
Oh, right. There was an error right as we come over, or I came over, so they're working through the error. Okay. Well, I think I'll hear it start punching, so once it starts punching, we'll come back and we can watch. Oh, here we go. Not yet.
Well, yeah, maybe like 5 or 10 minutes.
Maybe 5 or 10 minutes and it'll be running it. We'll hear it when it starts. This is a cold saw. So those aluminum extrusions are put on this rack, rolled down into the cold saw. It's a cold saw because it sprays coolant onto the material as the saw comes down and cuts it. So we're cutting it into different lengths for parts that will then go into the mill and be milled. Okay. Let's see. It does have a lot of stuff. These are the parts that end up being cut off. This is used for a PCI brace. I'll show you the final product afterwards. But the PCI brace is even milled out of a solid aluminum block. It's no plastic. And this small block for launch heavy, this turns into the lifter bar for launch heavy eventually. One of the things we really
yes, I heard yes.
One of the things we really didn't like about existing keyboards were those plastic flaps that always end up breaking off. So we made really high quality lifters for getting a different angle on your keyboard. Let's see. This is our sander. After a part is cut, this is a Thelio Mira or Spark, and it comes off as a flat piece like this. There's a little bit of slag on the edges from the lasering process, So what the sander does is remove all of that slag, and it comes out as a nice smooth piece. It also removes oxidization from the aluminum because paint can't adhere to oxidized aluminum, or doesn't adhere as well. And so it removes that layer, making paint adhere better. Has a vacuum table, so it just pulls down the part. Inside is a drum and a belt sander. And so it goes through 2 sanding processes on the way through. This is one of the mills. It's not running at this time, but this mill is used to produce launch keyboards. Since launch keyboards are milled out of a full block of aluminum, they have a different shape that can't go through the sander. And so this is the sandblaster. The part goes in, and you reach in with your gloves, and you grab the hand, and you grab the sandblaster, and you sandblast the parts.
Okay.
So for parts with strange shapes that can't go through, that's the tool that's used for that. Even the bottom case, this is the bottom of Launch Heavy. This is even, I believe this is 2 millimeters. It's very thick aluminum. And these features are milled out so you can see where magnets are going to go in.
Okay.
And then this is where the magnet bar, the lifter bar goes. So steel plates here, because aluminum is non-ferrous, it's not non-magnetic. The steel plate goes in here, and the magnets come in from the bottom side, and that's how the lifter bar is attached.
Yes, that's a lot of new keyboards coming very soon.
These are the PCI braces. So when you think about a GPU, it has the fingers that come out and attach into these standardized positions. So as the GPU is installed into a Thelio desktop, the GPU is held by these, and then another cover that comes across. But we didn't want flimsy plastic or anything that could possibly break, so we make these parts out of aluminum and solid blocks. So it's extremely high quality again. And these are these are the lifter bars that go on the bottom of the Launch Heavy. Again, made out of aluminum. Let's see. And here's a Launch keyboard. This is before being sandblasted, but that block of aluminum you saw at the beginning was made into this part, which is the top housing for the Launch keyboard.
Launch is nice. Oh my god.
Oh, let's see. And so you can see the parts together. We have the top, and then we have the bottom, and these eventually are married into a single product.
And do you produce like PCIs yourself, or
Produce with?
like PCIs, like the thing like where you attach all the keys and the like microprocessor for the keyboard?
We don't produce motherboards. We don't have SMT machines here, so that part is outsourced. But we do all the electrical design.
Okay.
These are compressors that provide compressed air throughout the factory. So from these, all the compressed air goes into these blue tubes. All the machinery in a factory, a lot of machinery in a factory, uses compressed air. And so it's centralized in one location and then spread out to different machines that use it. Let's see. All right. This is our brake. So a flat part starts out looking like this. A program is loaded. The program, you see these lights here? The program will tell you what dies go where. And so we position the dies based on the lights, and then the backstop is automated. So the program will run and it'll tell you which order to put the part into the brake and then make the bend. And this part, flat part, becomes this, which is part of a duct for a Thelio Prime. And here we see the flat parts.
Every single part just looks too beautiful.
Yeah, right. And this is the part, we saw the Thelio Mira part over there. This is the part after coming out of the sander. where it has that nice finish and all the slag's been removed. Let's see. And over here, so you can imagine, we've cut the parts, we've sanded the parts, we've bent the parts, and then this is the storage for the bent parts. And here the desktop's starting to come together. We have the side and the bottom, and now those have been riveted together. And then over here, this is a PIMsert machine. So what's happening is that these very small steel PIMserts are being installed inside of the aluminum. And the reason we do this is that aluminum is very soft. And because it's soft, when you're installing or removing screws often, eventually those threads start to break when you're using aluminum. And before, when we were using cases from other manufacturers, it was very common that the threads would break over time, so they weren't very durable. So we wanted steel, and that's why we did the PIMsert machine and PIMserts. So if you look here, you can see the PIMserts inserted into the material, the various places where a thread is needed. That's another characteristic of the quality that's different with Thelio and the Thelio product line versus most desktop computers. It costs more to do, but your longevity and durability is far, far greater thanks to those small design decisions. Behind us here, this is our CO2 laser. We use the CO2 laser for different materials that a fiber laser doesn't work on. The other large laser you saw was a fiber laser, and fiber lasers don't work on acrylic or wood. And so this CO2 laser is used for those materials.
Lots of lasers, lots of...
Yeah. Here's the top of launch after being sandblasted, so you see the difference in the finish.
Yes, this is very different.
And here are more bent parts that now have been fully assembled. This is a duct for a Thelio Major or Mega. It might be one or the other, but you can see the quality of the finish and the craftsmanship. Here you can see the outside of Thelio and how it starts. These pieces are put together to ultimately become the entire exterior. All right, let's see. This area is an assembly area for parts. So like the top of let's see, this is a bracket for the top of the Thelio Prime. And this area is where the team will do things like, this gets affixed to this part. And then this is the top of a Thelio Prime. And then the other sides are adhered using a 3M adhesive. Adhesives are they're basically the new welds. Instead of welding things together, the adhesives have become so impressive that they're actually, in many cases, better than using welds. And we use the type of adhesives that are used in aeronautics, like in planes or cars or other things that are holding up parts together. It's much cleaner and much easier to automate in a factory process. Let's see. All right. Here are accents that have been made. So,
yes.
This is the part of the aluminum that's painted for the different colors, and it's adhered to the top, and that becomes the Thelio mirror accent that can be changed on the front.
Yeah, I like this one.
I do too.
Yeah, I love this.
So I designed this one actually. So,
really?
so it has a special place.
Taste.
Yeah, a special place in my heart. And at first we didn't think that our laser could do something as detailed as this, but it turned out after we started doing testing that, sure enough, the resolution is high enough that we could do that type of artwork.
Yes, this is insanely high resolution.
It's incredible, isn't it? I'll show you that laser next. Okay, so it's over here. This is our etching laser. So we use it for all labeling. We don't have a finished part, but we don't, we build such a high quality product, we don't want to put stickers on it. And so instead of stickers, we use these plates, and then we etch things like the model number, certifications, serial number, and so forth on metal plates instead of using stickers. All right.
Yeah, should we close it?
Oh, it'll be okay.
Okay.
I'll go ahead and close it. And we've got Bob Ross there to help us out.
Yeah.
All right. Next is the paint room. So those parts come into this room where they're ready to be painted, and we use powder coating. That's what Rachel's working on over there. So we remove the oxidization from the aluminum with sanding, but sometimes there's oxidation that occurs quickly, and so even before it gets into here, some oxidation might have occurred on the surface. So the parts go into a acid dip, and that removes all of the oxidation, and then goes into a rinse tank. It then goes into the oven where it's dried and warmed up. Warming up helps the powder adhere to the material. And then Richell rolls it into the powder booth. And in this booth, the rack itself is grounded. So there's a big ground cable going down over to the side. And then what the gun does is positively charge the particles that are coming out, the powder particles, and so they cling to the part. That means that before it goes into the oven and it's cured, you could just blow it all off. Like these parts haven't gone in yet. You can see like the sparkles in there, and how different it looks in the final product. Once this rolls into the oven, over a period of, I think it's about 14 minutes, if I recall correctly, the parts start to, the paint starts to flow. And when it flows, that's when it becomes one solid surface. We like powder coating because there are no VOCs. It's much safer for the environment. It has a nice scratch resistant, fingerprint resistant surface, and for all those reasons we chose powder coating as our finishing technique on Thalio Mira. This section here is our keyboard assembly section. So after all those parts are completed, we bring them in and we start assembling them here. It's been a while since I've been in this section.
Yeah, I think there's like an assembled keyboard here.
Yeah, there's those parts, and we have, oh, here we go. So this is the PCB for Thalio
PCB,
Launch.
yeah, I said PCI. Yeah, PCB.
Ah, yes.
Okay.
That's where the confusion came from, right? Yeah, so here's the PCB. What's unique about Launch is that it has a high-speed USB controller on it. So these are USB 3.2, and this is the USB controller. One of the things we want to do is both make ports more accessible in a place that makes a lot of sense. So when you're using your keyboard and you need to plug something in, it's right there for you instead of trying to find it on your desktop or worse, perhaps trying to figure something out in the back of your desktop.
Yeah.
They're in the most convenient place possible. They're also high speed, so you're not losing any performance plugging a device into Launch versus plugging it directly into the PC. That does add some cost, but you're kind of getting two products in one. You're getting a really high-end keyboard and you're getting a high-speed USB hub at the same time.
You have like a huge hub, like how many? 3 Type-C, 2 Type-A.
What's that?
I mean, like you have 3 Type-C and
right.
2 Type-A.
This is the input.
Yeah.
So yeah, you have an input, and then yeah, you have 2 USB-C and 2 USB-A to use as a hub.
Yeah.
And then here's the controller. We're using QMK open source firmware. Of course, all the open source firmware, or all the firmware is open source. The electrical design is open source. It's open hardware, and you can see it's a little Raspberry Pi controller.
Yeah, that's interesting.
So this is assembled into the case, into the Launch case, and over here we have a couple of machines for producing Launch keyboards. This is the switch installer. So we have a hopper over here, and different switches go in depending on what the manufacturing orders call for. The hopper blows or circulates and then blows the switch down to the end here. The top goes onto this case, and then as it's operating, it moves the top around and installs all the switches. When we started out, we installed them by hand, and we would have the whole team coming in, pushing them in with their thumbs, and by the end of the day, we couldn't even feel our thumbs. So we didn't anticipate the demand being as high as it was, and we started adding machinery afterwards as it became clear that we needed to scale up for the amount of production we need to do. These two machines put the caps on the keyboard. So after the switches have been installed, the keyboard goes into the machine, and an entire tray of keycaps is installed all at one time. And then this is a OCR, optical recognition machine, optical character recognition. So what it's doing is, sometimes we'll get sometimes the tray will have a character in the wrong position, or it'll have the cap moved 90 degrees or something like that. This is a quality check to ensure the legend matches exactly what the legend should be. And it's also one of the final checks we do because it's very high resolution as well. It can detect like an eyelash on the keyboard. So it also ensures there's no dust or any other things that we might miss. So we do a final wipe down, goes into the OCR machine, and then it's boxed up and ready to ship to a customer.
Yeah, and what happened with 65 with Super, for example?
There's something it doesn't like here. I can't tell exactly what it is, but yeah, and also on this home key, yeah, it feels like it's off a little bit, and it might be a matter of the tolerances on the OCR machine that we need to adjust for those keys.
Yeah.
Okay. Before we get to that final step, we have a testing step, and that's what these machines are for. So after the motherboard or the PCB is installed, and then the caps are installed, it goes into one of these two machines, and because Launch Keyboard has in-key rollover, we can detect every key pressed at once. So we use this machine to depress all the keys, and then the software reads whether all of them was read correctly. So that ensures that the switch is properly seated inside of the hot swap socket. After we've done that once, we do one hit, and then correct anything that's wrong, and then we put it back in and it goes through 100 hits. What we found is, as long as we make it to 100, then we haven't had any problems whatsoever for years afterwards. So that's our testing number to ensure that everything is working properly. This machine does kind of the opposite. One of our switches is quite sensitive, and we've had some issues with them coming in, and the switch will activate too early. And so what that does when someone's typing is you'll get like a whole bunch of Y's or a whole bunch of S's if that particular switch is activating too early. And so in this case, we blow on the switches with enough pressure to ensure that it's not activating early. This is all the rejects. So these all activated too early, and so they ended up in the reject bin. And these we all made in-house, all the software, all the systems itself, because we identified things that we wanted to ensure were good for quality, and we built the machines ourselves.
Yeah, and what is the rejection rate? Let's say like 1%, 0.5%, or?
I don't know, but it's small enough that it didn't mean changing out the switch itself. But I don't know the exact figure.
Yeah.
Let's see, here is the top housing after it's been painted.
Lovely.
And here's the bottom after it's been painted.
Yeah, I love this one.
This is the etching that you see. Instead of a label or even paint, it's etched into the, we're removing the powder coat to create the labels using the laser. And then these parts go together, and the PCB is installed into this. Then the top is installed and screwed in. Then the switches are added, and then the keycaps. And eventually it becomes a full launch keyboard. Here's a launch and a launch heavy with the keycap or with the switches installed. and with switch stabilizers. So for 2U switches, we use stabilizers so that the cap doesn't move side to side when you're depressing it.
Yeah, I remember opening the box and being amazed by these high quality cables.
Right.
These were like, I had never seen such a high quality before, like getting the keyboard.
Yeah, everything is carefully thought through. We geek out to an extreme extent on every part. Here we have the launch keyboard, PCB. The same keyboard is used for launch heavy, and then there's a second PCB that's used for the numpad, and it's connected via a ribbon cable. That way we can produce one, especially with the USB hub, a rather expensive part instead of two separate ones, and then just do the add-on with the numpad PCB.
Yeah, because I thought it was like one PCB.
Right, in this
and
case.
It's actually like the original launch and then you add a numpad.
Precisely, right.
Yeah.
And we made some adaptations to the PCB to add that on, but it's a more efficient way to manage inventory, manage costs, and without it removing any quality of the product.
Yeah.
This side of the factory is all operations and QA, so that's the team that does our design, that does QA, that does ensures the factory is running smoothly, that the manufacturing orders are matching the orders that are coming in, and with the correct amount of excess stock, and keeping everything running thin, but also fast enough that we can deliver orders quickly to customers. And that's about it. That's the build and production teams and the processes we use to build all our products.
Yeah, now to the Virgo.
Virgo, yes.
Yeah, Virgo. Where is my Virgo? I'm gonna buy prototype.
Yeah, it's a very big project, so we'll see when it gets here. But we have a lot of cool things rolling already.
I'll be one of the first ones to buy. I can guarantee you that.
Appreciate that. Great.
Yeah, thank you for this tour. It's actually been pretty amazing to see all this machinery and how everything is built. And it's amazing to see how pure aluminium is transformed into the keyboard I've used for more than 4 years.
It's incredible to, there's a huge satisfaction in making things. Like, it's great to design things, and there's a lot of satisfaction in that, but when you take it to the next level where you not only design it, but you manufacture it, you can iterate much faster, you can do R&D much faster, you just do things that you can't do if you're limited to just doing design. So manufacturing has been pretty special for us.
And the last question, how are you going to celebrate the anniversary?
It's funny.
I asked you on Twitter.
Everyone is asking me that, and I still don't have a good answer. We'll figure something out.
Yeah. Okay. Thank you for this tour.
Yeah. Thank you for coming. That was the first meeting at the factory.
When was it? Like how many years ago? Wait, is it Jeremy on the right?
Yeah, there's Jeremy.
Oh my God.
Yeah, it was 2017 or 18. Gosh, I think it was probably 18. Yeah, it must have been 18, maybe 19. But this was this is what the first meeting, and the factory was completely empty, and that's how it all started.
Yeah, that's a huge transformation from empty to like, how many different machines do you have here? Maybe like 20, 25?
Yeah, at least. It's a lot.
Yeah, and you're going to get even more.
And yeah, we'll need more. We're already thinking that when we fill this space up, do we have enough space for the things we want to do in the future? We're not sure. So
yeah, you can extend to other things.
Yeah, so we might be expanding or moving. We're not sure yet, but it's on our mind already.
Yeah. And now the machine seems to be working.
Yeah, all right. So they have our laser punch machine working now. And here you can see it dragging the sheet back and forth, and it's doing all the punches. Sometimes when you have a shape that you're putting or cutting out of the metal, at first you might do it just using the laser, But then if you do that shape over and over again, it's faster to buy a punch, or faster to use it, buy a punch, and do that instead. What part are we making? Oh yeah, so this is the GPU base. One of the challenges being a computer manufacturer, especially when you do really high-end stuff, is GPUs, because they're so big, making it through UPS and getting delivered without any damage. So this is part of a GPU brace. It'll go through the sander, it'll go through the brake, and then at the end of the day, it'll be shaped into a GPU brace with different positions, because GPUs come in different lengths, different widths, different heights. So these are different positions to put parts that are added onto it and secure the GPU into the system, so it makes it from the factory all the way to our customer's home or business.
Yeah, and the spaceships makes it even faster.
This is a perfect example. So we used to cut this out with a laser, and then because we were using it throughout our designs, we bought a punch, and now that's punched instead. Although this one looks like it was laser. You can tell the difference between punch and laser, because the laser will have a little bit of slag, and the punch has this very slight deformation around where the punch happened.
Yeah. So different.
Yeah.
Perfectly shaped.
Yeah. And they're different sizes for different reasons, because they're used for different purposes. So we have one size here and one size here. So it's still going through the punch operation. How long before it starts cutting? Might be a while. Maybe 5 minutes. So now it's doing all the punches first, and then it's going to come through and it'll start cutting out the shapes that are done with the laser.
I fast forward, but I can't.
Thanks for getting this rolling.
Yeah.
Nice to
Let's
see.
just wait for it.
Yeah.
Here we have a punch.
So this is.
Yeah, I don't know what exactly the size is.
But close. This is a good one to pull.
And then, so yeah, like the punch is kind of like what goes through the material, and then the die is just more or less an opening a little bit larger than the punch. And so it just kind of supports the material while it's being punched out.
Oh, okay.
But yeah, so we have different sizes for different materials and thicknesses. Yeah.
Hey, can we take a look in the IPG real quick while we're
Let me go get it turned on.
Great.
It won't open without it being.
Okay. So I can tell you a story about the IPG when it gets that turned on, and why we added that laser to our machines. You can see how fast punching is. It's making a lot of different shapes very quickly in the material. And as I've mentioned before, it doesn't transfer any heat. So with enough heat, any material will deform. So you have to be cautious in your designs when you're using a laser, when you're using a punch or other forming features.
And Trumatic, is it like an American manufacturer or?
This is for the laser itself.
Yeah.
It's Trump, which I'm pretty sure is German.
Ah. Yeah, makes sense. Germans are quite advanced in this machinery.
Right. So does the IPG need to warm up?
I don't have anything to run, but we can move it around.
Okay, yeah, let's take a look.
All right, pretty close.
We're thinking close? Okay. Ah, well, we can come in closer here. So the blue is the parts that have, or the features that have already been punched. And you can see it's just going to run through and complete these. It's changing the head right now. Looks like.
Yeah. So yeah, right now it's cutting out the oblong.
Ah, right.
So yeah, the punches are kind of cool. Like, you can have round punches, but you can also have, or Trump calls it an oblong, but it's an oval.
Right.
And so now we're gonna laser.
Okay, so now we'll have to stand. We can't cross this line right here. This is a laser line. The machine will stop if we do that. But if you come on over here, you can see through this window. Now it's going to eject the part. So that's the completed part.
It's going very fast.
It's a fast laser. I believe it's 3 kilowatts.
It's a little bit warm, it's not hot.
Yeah, you can feel it.
Yeah. How long would it take one to do it by hand?
Oh gosh. That would be a pretty detailed and difficult job. I have no idea. But it wouldn't be the, I don't know, maybe 50 seconds per that it takes the machine to do this. It's since the part didn't drop, and so now it's because the part didn't drop, it tried to shake it out. But if that didn't work, now it made that little noise to call an operator to check. And now the part dropped out, and the machine will be restarted. And there we go.
And how does it work? Like, do you produce these for, let's say, a couple of hours a day, and then you switch to another part, or?
Yeah, essentially, and there's a balance between, like, the operations team determines how many parts for each thing needs to be produced, and then generally it'll be like this, where we're using one sheet of aluminum that looks like it's probably 2 by 8, and we're using that 2 by 8 sheet to produce all of these parts. So we also try to optimize the number of parts we get out of one sheet of aluminum. Oh, let's go take a look at the IPG. So this machine is called Laser Cube, and it was it was the result of the success of the launch keyboard. Because when we start with the launch keyboard, think over here. When we started the launch keyboard, each one of these sockets was milled out. And when you have sharp corners in a mill, that takes a long time because you have these end mills that go in, and you start with a larger one, and then you have to gradually get smaller until you can make a sharp corner. But that takes a lot of time on a mill. It would actually take about 40 minutes just to cut these out on the mill.
Just for this one part?
Just for one part. So we couldn't produce enough launch keyboards for the amount of demand that we had. So that's why we bought this laser, because you can't put this part on the other laser. It won't drag it around. It just can't be done. And so we added this one, which is a flatbed that doesn't move. So the head moves in all the directions. And another thing that's really cool about this is it has an optical recognition system that will...
Let me see if I can find that.
Okay. What's cool about it is, you can see this is our template for positioning all the keyboards. So this will be completely flat when it goes in this machine. And then it will come in, and you'll see if we have an unprocessed one, there's a hole here and there's a hole here. So the optical system can orient the laser to these guiding holes that will be right here, and so it'll get the correct orientation every time. So you don't have to be extremely precise, because the laser can orient for it. We went from 40 minutes to cut these out to a
10
minute.
seconds?
Not quite that close. It was about, I think it was about 90 seconds.
Oh, okay.
So now we'll install a different jig. This is the jig for launch heavy instead of launch light. Can I show them the unprocessed part real quick?
Yeah. I'm not going to be able to process.
Oh, we won't be able to cut it? Oh yeah, I can see that. Yeah, so this is what it starts out as, and this laser, using these and the template, will go in and cut out all the pockets for the lasers, or for the switches. It's very fast. It's, I believe, 4 kilowatts with a peak of 5 kilowatts.
And now this AI-powered machine will do the job.
We'll see. I am curious how different techniques might use might use the AI in the factory in the future.
So yeah, it's not going to cut anything, but
Yeah.
we can kind of watch the. I'll put in a name on the system, but
Yeah.
you can watch the locating. So if you look at the controller, you know, like Carl was saying, we have these reference features. Or like Carl was saying, we have these reference features. So the camera is locating that. Now it's finding the second reference feature, which is for angling. And unfortunately, it does this a couple times. But now we've got like the part, sort of say the 0, 0 position, but also because like we don't know if it's at an angle or not. Like the machine has to sort of say fix the angle by software. So it's just rotating the part and then cutting it based on where it actually is.
Right. And then once it has the correct position and it's oriented itself to that position, the laser will come in and start cutting. We can't cut this one right now. It's not prepped for cutting, but there'd be a lot of sparks if it was.
Yeah.
It's a lot of fun to watch. And it's incredibly fast. And it's been, so we brought it for launch and launch production, but it's really handy for a lot of things, especially with prototyping. Setting up the large laser takes a lot of effort and time, whereas we can take a small sheet of aluminum, drop it in here, and then cut out another test part that R&D or design might be trying out, just to see what we might be able to improve in the products. Yeah, thank you very much.
Yes, thank you.
I don't know if y'all wanted to see the mill.
We'd love to, yeah.
Yeah, Alex got it set up so we can look at the warehouse.
About how long you think?
Immediately.
Oh, great. We'll just walk on over there.
This is the first tour of any factory, and it's detailed to the maximum.
He's a little shy about strangers. What's this called again?
A surface plate.
So this is really cool because it's a surface plate that has a perfectly flat surface over a large area. It's just a massive granite block that weighs a lot, and it's used to ensure the parts that come out of the mill haven't been distorted in the process of milling them.
Yeah, there's an episode of Rick and Morty where Rick talks about like perfectly flat surface, whenever they were talking about that, I just thought of a surface plate.
Yeah, it's a quality tool. This is what it really is, to ensure that you're not, that every piece comes out as high quality. It doesn't take a lot of surface to identify where a part might be distorted in a way that means it isn't meeting our tolerances.
How long have you used it?
Since we started doing milling.
And what happens here?
Oh, I don't know. Somehow something took a little chunk out of it.
Yeah.
So right now he's preparing the mill. And what are we going to process?
The
Launch heavy bottom?
Yeah. So yeah, like on the IPG we were cutting the top part, the upper housing, and then on the VF3 mill we're cutting this the lower housing. The part starts as a 4x8 foot sheet of material on the Trumatic, and we cut them in pairs. So like it's kind of hard to see, but there's two of these parts in this blank of material. So we cut the blank out. We just like cut the perimeter, punch the holes, and then we're going to go into the mill, and that's where like we'll do our depth work. The Trumatic is good for doing 2D stuff, so like going through the part, but you can't do like partial depth. So that's where we have to come to the mill. So we're using a vacuum table right now. So for milling, typically the hardest part is holding the part. And so in this case, we decided to use a vacuum. So we're just creating a vacuum under the part, and that holds it down so we can machine the entire perimeter of it. So yeah, like more or less rigidly held now.
There's a lot of different pressures. Yeah, there's a lot of different pressures involved with milling, and so you have to have that just right. So one of the most dangerous things about milling is when a part might fly off the table.
Yeah.
You're going to see a lot of fluid start coming out.
Yeah. Yeah, and a couple, like right now what we're doing is we're locating the part. So kind of similar on the IPG where like, you know, let's say this is a machine axis. We don't know like where the part is, so the machine has to find it. So the IPG can use the camera. Typically on a mill, you use a probe. And so it's basically just a little ball that goes and probes features on the part to find where it is.
So that's going to change the head?
Or
oh,
it has to find the second one first.
It has to do the second one first, right.
Yeah.
And it changes everything automatically?
Yes, based on the program. And you can see it's doing some checks on the top, and now it's going to check the side of the material. And see, now it's just checked the side of the material to know where the side is. And now it's going to change the head. And it begins.
Yeah, it's like 25 minutes, so probably
Cut the entire part?
yeah. Or I don't know how long y'all wanted to watch for, but
Well, yeah, for a bit it's fun. You get the idea. Because basically it's going to look like this for 25 minutes. But it's dumping a ton of fluid to keep the part really cool and to eject the other
chips.
the chips. Thank you. Yeah, the chips that are coming off of the part as it's cutting through them. And here's all the chips in the end.
Oh my god. Wait.
It's very sharp.
Yeah, that's why I'm very careful.
Yeah. There's an auger in the bottom front, and the auger is pulling the chips up and through and out and dropping them in there.
And how do you use these sets?
It varies. I don't know, how many tools do we use for all the parts we make?
Like 15 to 20. We can hold 31 tools in this machine.
Okay.
Yeah, and like the Trumatic, I think we can hold like 15 or 16. But that, you know, different style of tools. So, yeah. But yeah, these are like, this is a cutting tool. That's called an end mill. And then this is a tool holder. So it's kind of like a bunch of adaptions to go from the tool to get into the spindle.
So whereas this machine specializes in spinning, the other machine specializes in pushing, punching things.
Yeah, and you specialize in creating everything.
That's the idea.
Yeah, what kind of machine would you like to have? Like, would you like to have like a 3D printer that would do everything for you, or
We have
would you still enjoy like doing it part by part?
We have a row of 3D printers. So we have there's the 3D printing section in the factory as well. And so some parts we 3D print, and then for the most part we use that for R&D. I don't know. What do I dream of? We have robotic arms that we use for automating some processes, and I think those are pretty helpful, because then we can do R&D with people during the day, and the robots can run the mills and other machines at night. So we can do some lights out manufacturing. That's one thing I'd like to do. Do more of that with more processes, just because it frees up people to do the really cool R&D stuff, and machines to do the R&D stuff. They're running at night without people needing to be here to watch them. Another one that I'd like. I want to test screen printing. I'm interested in screen printing some things. You could do a large variety of different colors of different. So it's good for like labeling and things like that. Like maybe screen printing would be a nice way to do labeling instead of etching. So I think those are the two that are top of mind, at least.
Yeah, what about printing your own chips? Yeah, microprocessors.
The long-term dream, I would love to have SMT machines and be at the point where it made sense. Sometimes, consolidating means you could do things more efficiently. Consolidating in manufacturing means there's a company that specializes in making PCBs, and they can get the right machine utilization so that they can bring their costs down of producing a board for you. That's where we're at when it comes to PCBs today. I think it would be really awesome to have SMT machines and be prototyping motherboards and making motherboards. I love making things, so I think it would be cool. Just doesn't make a lot of financial sense right now.
Yeah. And what are some of the machinery you're waiting to be delivered and installed here?
We don't have anything new coming in right now. So at the moment, we have all the kind of machinery that we need for producing the parts that we're thinking of and parts that we're producing today for machines and stuff we're thinking about for the future.
Yes. What is this blue machine again?
So that's part of the sander.
It's all like one single machine. Okay.
That's the exhaust system, and so it's pulling everything in. And inside of it, there's a liquid that the sanded metal goes into. It just becomes this kind of nasty aluminum sludge stuff that we have to pull out every, I think it's every couple of weeks or something like that. But one of the fascinating things about that machine is, you see that big pipe at the top? Mm-hmm. Well, when we first installed it, that wasn't installed. And when we turned it on, it was crazy how loud the thing was. We thought, there's no way this is going to work, because we have people working in here and operations and design and R&D and QA and everything else. And then the company said, oh, we didn't install the muffler. So that is a muffler, and and you can see it, you can hear how quiet it is now. It was unbearable to be around it, but that muffler made all the difference.
Dog is a bit more loud than all the machinery.
Yeah.
Yeah. Does it live here, or like you?
What's that?
Does the dog live here, or?
He is
like security dog or something.
He's Michaela's dog. And a lot of people bring their dogs to work in the factory. I think his name's Azkaban, if I remember correctly. And he's just a little shy around new people.
Yeah, and we've got the new parts there.
Right.
Very shiny, very polished.
Yeah, part. You're gonna flip it around to the other side? Here, let's send it through. So here the table is grabbed apart, and as I said earlier, it's a vacuum table, so it's sucking it down onto that belt. It's really nice because you don't have to do special fixturing or anything for it to get through. There's a big drum right here that's sanding it, and then there's this is the belt sander, and there's a big drum sander here that's spinning around and doing another pass on the part. And then they come out slag free, and it's a lot of oxidation, and any minor flaws that were in the material have been sanded away. We used to do all this by hand, and it was literally with DeWalt or Ryobi sanders, and we had a very small team because we built all of this organically, and so I used to sand parts as well when we were starting the early process, and I remember your hand would feel like it's shaking afterwards because the sander shook so much. Now we don't have to do that anymore. Big industrial machines are producing the parts.
Yeah.
That's metal. Just talking to it?
Yeah.
All right, this is Britton. Britton is our mechanical engineer and does all the design on the Thaleo line and a lot of our R&D. And so one last section of machines that we hadn't covered yet was our 3D printers. And so I'll let you take it away with the SLA.
SLA printer.
SLA
Sorry,
printer
you got
and
me
the
confused. So this is our SLA printer. It prints in resin, and we use this for some small detailed plastic parts that we use inside of our chassis. Right here, it's kind of hard to see, inside of there is they're like little finger nubs. They go on the tip of our what we call our GPU fingers. They kind of sandwich the GPU to keep it in place during shipping, and we use it for small, highly detailed parts. And we have two different forms. One's used for R&D, and then this one's used for production. Similarly, we have an FDM printer. This prints PLA filament typically, and we also use this for a few small parts inside of the chassis as well, and also a ton of R&D. That's an easy way to test our parts and produce things fastly in the prototyping phases. But the parts that we use inside of our chassis, they're typically small little plastic pieces used as rub guards and stuff like that, just to prevent the powder coat coating from rubbing against each other and scratching the chassis. But yeah, that's pretty much what we use.
What's your favorite 3D printer?
I love this one. This one's great. It's super fast and super accurate. A lot of previous 3D printers I've used, you have to really dial in the slicer settings, but Bamboo has their technology really dialed to where you just upload your part, you can kind of auto-orient it and maybe add whatever supports you need, but you don't have to mess with any of the slicer settings except for maybe the infill density. And it's really fast and it's super accurate.
Yeah, did you program it yourself or was it already pre-programmed?
It comes pre-programmed from the factory. You can, if you want like custom slicer profiles to speed up the prototyping, you can make it have a lower infill density. You can speed up the print speed and stuff like that. So if you want a really quality part, you slow it down, you make the infill a little bit higher. Or if you want a fast prototype part that I'm like, okay, I got to get this design done today, I need this print in 15 minutes, you can also edit the settings to kind of adapt to that as well.
Yeah, and how often do you even use them? Let's say 50 times a day? Or?
It totally depends if I'm in design mode or what I'm doing. But if I'm designing, I'd probably say I use it maybe once every 2 or 3 days, or I usually use it in batches, I would say. So if I'm designing, I'll do like maybe 3 prototypes within a day, but I'll use it maybe like twice a week.
And what kind of modifications would you like to add to the printer? Yeah, let's say make it faster or...
I'd probably like to try some different filaments. I haven't looked too much into what Bamboo's capabilities are, but they have some really cool like carbon fiber filaments and some glass fiber filaments that are really rigid. I know nylon's a really good one as well. But PLA is typically the easiest for prototyping, so that's typically what we print in. As far as modifications, maybe a better enclosure. The little tint setup works well, but I know Bamboo also has custom enclosures that they sell that improves it, and they also have I forget what you call it, but it's like an auto filament changer, so that if I wanted to do something like ABS, something that has like more UV resistant properties or more thermally stable, then I could use like ABS or ASA or something like that.
And what was the last part you printed with it?
So I printed a little prototype for a magnetic connector. It's a magnetic fan connector, and it holds the magnetic connectors in the right place so they mate properly.
Yes, that's very cool.
Yeah, it's fun. I can't wait to get one for my house. If I'm going to buy one, I'm probably going to get this brand too because it's pretty easy to use.
No, that's an advertisement.
Oops, didn't mean to do that, but I like this one a lot.
They have to pay you. Yeah, thank you for the introduction.
Yep, thanks for talking to me.
Yeah.
There you go.
Thanks, Brendan.
No problem.